Welcome to Unit 13, Part 3 on more page replacement algorithms. So in the last video we did first in, first out and optimal page replacement with this same reference string. And we noticed that first in, first out gave 15 page faults and optimal page replacement gave 9 page faults, and that's why it's called optimal. And this is another technique called least recently used. And what it does is it replaces the page that was referenced the farthest in the past. So if a page has been referenced in the meantime, since in first out, it doesn't matter if it was referenced again or not. In the least recently used, if it has been referenced, it's not going to be replaced. So I think it's better to just do the exercise and maybe you'll understand it better. So once again, we have our first 3 page replacement page faults. Don't forget to count the first 3. If the page is not in a frame, then once the page gets put into a frame, you will have a page fault. Now we need page 2. So if we take a look at the pages, we have recently referenced page 1, and before that page 0. So the least recently used page is going to be page 7. And now we need page 0, which is already in a frame. And now is where you can see a difference between first in, first out, and least recently used. Because now we need page 3, and since we have recently used page 0, we're not going to be replacing it, and we're going to replace page 1 because page 1 is the page that we used the farthest in the past. And now we need page 0, and it's good we didn't replace it because it's already there. Now we need page 4, and we just referenced page 0, so we're not replacing that one. And right before that, we used page 3, so we're not replacing that one, so we're going to replace page 2. And now we need page 2, and we just looked at page 4, and right before that page 0, so now we will replace page 3. And now we need page 3, and we just referenced page 2, and before that page 4, so now we will replace page 0. And now we need page 0, and we just referenced page 3 and page 2, so we will replace page 4. Page 3 and page 2 are still there. And now we need page 1. We just referenced page 2, and right before that page 3, so we will replace page 0. And now we need page 2, it's already there. We need page 0, and we just referenced page 2 and page 1, so we'll replace page 3. Page 1 is already there. Now we need page 7, and we just referenced page 1 and page 0, so we will replace page 2. And page 1 and page 0 are already there, so we now have 12 page faults with this. And usually that's the way it will turn out, that first in, first out will give the most page faults, optimal will give the least page faults, and least recently used should do better than first in, first out. Least recently used is much harder to implement than first in, first out. It's a lot more implementation. First in, first out is just a basic queue, and least recently used, you can use a stack or a counter in order to implement, but it's a lot more expensive and it takes a lot more work to implement it. So some systems, instead of implementing the least recently used technique, they will implement a least recently used approximation. Now one of them is a second chance algorithm, and it uses a reference bit. So like I said, in your page table you have some different bits, and one of those bits is a reference bit, and the reference bit indicates whether it's just a bit that is a 0 or 1, and it gets set if a page gets referenced, and it gets cleared when a page gets passed by. So that's one way to do it. You can use a circular queue with just an extra reference bit rather than having to do an expensive stack or counter implementation for least recently used. This is an approximation, and it should usually give better results than just plain first in, first out. So let's take a look at the least recently used approximation, or the second chance algorithm. And I have implemented a little animation to demonstrate it. This also demonstrates the valid bit, because sometimes it may appear that a page is in a frame, but there's a bit when it gets replaced that you have to clear to indicate that it is no longer valid. So I've only done a part of this animation, but hopefully this will help you to understand what's going on. So right away we need page 7. So we're going to find our free frame list, and we're going to put page 7 into frame 0 and indicate that page 7 is in frame 0 and it's valid. And now we need page 0, and we're going to have a page fault. And now we need page 0, and page 0 is not in a frame, so we're going to put page 0 into frame 1 and indicate that that's valid. And then we will put page 1 into a frame, and it's valid. It's in frame 2. So we have page 7 is in frame 0, page 0 is in frame 1, and page 1 is in frame 2. And now we need page 2. So we have to select a victim, and this is first in, first out with a reference bit. Nothing has been referenced yet, so we will replace page 7. Now if you take a look there, you can see that page 7 has been replaced. So although it says that page 7 is in frame 0, it's no longer in frame 0 because it's no longer valid. Because now in frame 0 we have page 2, which is valid. And now we need page 0, which is already in a frame. So we don't. What we're going to do now is, since page 0 is already in a frame, we're going to set the bit to indicate that we have referenced that. So page 0 now has a reference bit because in the meantime, while it was in the frame, it was referenced, and that's the bit that's going to give page 0 a second chance. And now we need page 3. So when we go to select a victim in the first in, first out, we would have selected page 0, but because it was referenced, instead of selecting page 0, we're just going to clear the bit, and then we're going to move down to the next location, and we're going to replace what we did is we went by page 0, we cleared the reference bit on page 0, and then we moved the pointer down to page 1 to the next location. Page 1's reference bit was not set, so now we have replaced page 1 and just cleared the valid bit, so page 1 is no longer valid, and we put page 3 now into frame 1. So into frame 2. So if you take a look at that, we used to have page 1 was in frame 2, but now it's no longer valid. We've put page 3 into frame 2, and we have passed up on replacing page 0 because it was referenced. And now in the next step, page 0 will get referenced again, and so page 0's bit will then be set again. And it will continue like this in a circular way, in a circular queue, just passing by. And if all of the pages get referenced in the meantime, then it'll just go right back to first in, first out. Some other algorithms that can be used are least frequently used and most frequently used, and just some kind of different techniques to try to select which pages to replace. And like I said before, instead of doing demand paging and having page faults, some systems like to try to anticipate which pages are going to be needed and pre-page some of those pages into frames ahead of time in anticipation. So that's another technique that can be used. Thank you very much. This concludes Unit 13, and I will be talking to you again soon.